This is the data set which I am using to create the basic equation which shows the relationship between the revenue and the promotional budget. I am using autoregressive model to create the basic equation. Now let's see how we are going to arrange data in order to create the autoregressive model. I am going to copy the independent variable data column and I am going to paste it here like this, creating the first order autoregressive model, then the second order autoregressive model, then the third order autoregressive model. Then I am going to test whether the third order autoregressive model is significant. That means I am using this set of data. So I am going to copy this set of data and I am going to paste it here. In this case, this is my y column, this is yt minus 1, yt minus 2, yt minus 3, yt minus 4. This is my dependent column and these are my independent columns. Now I am going to find the relationship between my dependent variable and independent variables. I'm going to data column, data analysis, regression, and this is my y data column. These are my x data column, and I am going to create the output here and press OK. So I got the results, and as you can see, this is the most important column here. When it comes to my p-values, my p-values are all greater than 0.05. I am testing this hypothesis. H0, the null hypothesis, is third order autoregression is 0. H1, third order autoregression is not 0. If p-value is greater than 0.05, that means at 5% significance, don't reject the null hypothesis. All the p-values are greater than 0.05, so all third order autoregression models are not significant. So now let's go to second order autoregression model. In order to take data for second order autoregression model, you have to select this particular part and copy this set of data into here, and then you have the y column, yt minus 1, yt minus 2, yt minus 3 column. Just like I did previously, I am creating the data output and I am testing the hypothesis, these two hypotheses. My H0 or null hypothesis is second order autoregression is 0, H1 second order autoregression is not 0. So in this case also all the p-values are greater than 0.05, and because of that you do not reject the null hypothesis. So all third order autoregression models are not significant. Now let's come to the first order autoregression model. Just like previously, uh, this is the data set that I am interested when it comes to the first order autoregressive model. Then I am going to copy this set of data here and create the y column, yt minus 1, yt minus 2, and I am creating the output here. As you can see, when it comes to the x variable 2, the p-value is greater than 0.05. That means do not reject the null hypothesis. But when it comes to this particular variable, the p-value is 0.02, where it is smaller than 0.05. So reject the null hypothesis and accept the alternative hypothesis, which is this. That means the first order autoregression is not 0. That means it is significant. So in this case, my m value is around 5.5 and my c value is somewhere around minus 449,000. With these two data, I am going to test my basic equation using NetLogo. Let's go to NetLogo, and first you have to, this is the main interface. First you have to press this main setup button, so it will reset everything. And as I have shown previously, my n value is 5.5 and my c value is minus 49,000. And let's say the random exponential mean is 1000 in the data. And when we put a random gamma distribution as the independent variable and run the simulation, you get data like this. Here, the total revenue is somewhere around 2.4 million, where the total promotion cost is somewhere around 452,000 and it is having around 1.9 million profit. So let's go to this thing. Here, let's say our mean is 1000, which is around 200. Let's run the simulation here. It's around 5.4 million revenue and 1 million total promotion cost. The firm will ended up 4.4 million in profits. Then when we put random Poisson distribution as the x variable with a mean of 1000 and run the simulation, the firm will get around 5.4 million revenue and around 900, uh, almost 1 million total promotion cost and 4.4 million profit. So those are the data that we generated by simulating this particular example. Then I have a summary of those profits and revenues. As you can see, when you use random exponential distribution, these are the revenues and these are the profits. And as you can see, when it comes to profit is highest when you use a random Poisson distribution with a mean of 1000 as the independent variable. So that is everything about my simulation, and thank you very much.